Welcome everyone to this week's Science News. This week we'll talk about 3 new laws of nature, one of which supposedly shows that we live in a computer simulation. We'll have a first look at intergalactic filaments, talk about building roads on the moon, whether chatbots understand what they chat about, a new type of qubit with a low error rate, sound waves in crystals, how to deflect lasers with nothing but air, dunes on Mars, the first hurricane prediction market, and of course, the telephone ring. This has been the New Laws of Nature week. There was not one, but 3 papers that put forward new laws of nature, and they were all pretty much on the same topic, the growth of complexity. They're trying to address a long-standing mystery. It's that complexity in the universe at large and in smaller systems within the universe seems to increase under certain circumstances. Simply put, the universe made us and we don't know why. The second law of thermodynamics seems to imply that complexity must eventually decrease because entropy will wash it out. But we seem to be missing a natural law that tells us in which situations complexity arises in the first place. The problem starts with even trying to quantify what we mean by complexity. The 3 papers are of very different quality. The first one's about something the author calls the second law of infodynamics. It's an idea he proposed in an earlier paper. In the new paper, he claims that this law is fulfilled and that supports the idea that we live in a computer simulation. The problem is that the way that he defines his new law is just identical to the second law of thermodynamics. It's not wrong, but it's not new either, and it's nothing to do with computer simulations. The second paper comes from a group of philosophers. On the upside, it makes more sense than the first paper because it's specifically about systems that undergo some kind of evolution. On the downside, it's mathematically vague. They proposed to measure complexity by a quantity called functional information that was introduced by another author about 20 years ago. It tells you, loosely speaking, how good a system is at fulfilling a certain function. In the new paper, they now call their idea the law of increasing functional information. So systems improve how they fulfill certain functions. The problem is, as they write themselves, that this functional information can only be calculated when you specify the function of a system, which moves the burden from figuring out what complexity is to figuring out what a function is. The authors of the third paper don't explicitly claim they introduce a new law of nature. They're a little bit more modest, but they address the same question. They do it with an idea they call assembly theory. The idea is that the complexity of an object can be measured by how difficult it is to assemble and how well it can make copies of itself. The good thing about this idea is that it's mathematically well defined. You can actually compute this quantity, at least theoretically. They look at some examples from chemistry to explain how it works. But just because you have a mathematically well-defined quantity doesn't mean it explains anything, so we'll have to see if this idea is actually good for something. There's much more to say about those papers. Let me know if you want me to make a longer video about this. For now, I'm sorry to say there's no evidence that we live in a computer simulation, and you'll not earn 2 extra lives by shooting down that floating cabbage. Scientists from the United States and Australia have for the first time seen intergalactic gas filaments. These gas filaments are mostly made of hydrogen. Because hydrogen is the simplest element, a lot of it was created in the early universe. If it clumps enough, it forms stars and solar systems and galaxies. But where it doesn't clump, it just lingers around and it's hard to see. And yet seeing this stuff is important to confirm that our model of the universe is correct. Measuring this hydrogen is really difficult. They did it by looking for a particular emission line of hydrogen known as the Lyman alpha line. If hydrogen atoms wiggle, this is one of the wavelengths they emit. The Lyman alpha line is in the ultraviolet when emitted, so we can't see it. But the universe expands while the light travels towards us, so the wavelength stretches and it's shifted into the visible range. These emission lines are faint and difficult to tease out of the data from the rest of the universe's light. They did it with an instrument called the Cosmic Web Imager at the Keck Observatory in Hawaii, using a sophisticated background removal technique called nod and shuffle. This entails shifting the focus of the instrument from the source you want to image to its background and tracking how the combination of both changes. Then you can identify and subtract much of the background. The sources they looked at were at redshifts around 2.5, so about 10 billion light years away. The volume that their observations covered is a slice of roughly 3 million light years wide and 600 million light years long, so it ain't small. If dark matter exists, which it may not, then it should fit with the structures of those filaments, so measuring them is another way to probe dark matter. It's an important test because most of the normal matter in our universe is actually not in stars, but floats around as such barely visible gas, either inside of galaxies or between them. Space is really a bit like society. The stars attract all the attention, but the real power is in the dark web. By the way, this video comes with a quiz on quizwithit.com. That's the fastest and easiest way to make your new knowledge stick. Scientists have come up with a way to build roads on the moon by melting the surface with powerful beams of light. As we get closer to living and working on the moon, we'll need roads because the moon is very dusty and all that dust damages vehicle engines. But building roads on the moon isn't as simple as it is here on Earth. Because the moon has a small gravitational pull, shoveling soil there will kick up a lot of dust and gravel. That's not the greatest working conditions. So these scientists came up with the idea of using concentrated light to just melt the soil. On the moon, they would use a 2-meter lens to concentrate sunlight, but down here in the laboratory, they tested it by using a laser beam with roughly the same power as the concentrated sunlight would have. They tested their method with mock moon dust that chemically resembles the real thing and was developed especially for purposes like this. Their laser was indeed capable of melting the dust into a liquid, which then solidified as a single structure. They studied the result with a scanning electron microscope and found that the crystal structure would make it strong enough to carry vehicles, so that's quite promising. The nice thing about this moon autobahn is that you don't have to worry about speeders. If they hit a bump, they'll just float off into outer space. Max Tegmark, a physicist at MIT, best known for his idea that all of mathematics is real, and his collaborator Wes Journay put out a new preprint. They set out to check whether artificial intelligences trained solely on language understand space and time. It turns out the answer is yes. The two looked at Llama, that's Meta's large language model, which is open source. They probed the network activation of the model for thousands of names of cities, global landmarks, famous people, headlines, song names, movie names, book titles, and anything that's plausibly related to a location and a time. Then they ran an analysis on the network activation patterns to figure out how well they fit on a two-dimensional map. It turns out the answer is they do so amazingly well, and indeed the spatial relations strongly resemble the correct ones. I found this to be very interesting because I argued in a video in March that the relations between words that we use to describe the real world necessarily capture some information about the physical world itself. Unless, of course, we live in a computer simulation, in which case I guess this isn't the real world and none of that matters anyway. Physicists at Harvard have made a big step forward with a new method of quantum computing. They are using single atoms as qubits, that's the units of computation in a quantum computer. These atoms are trapped with optical tweezers that are laser beams which can hold and manipulate atoms. I just told you in an episode the other week that atoms and tweezers are one of the newcomers in quantum computing. Compared to trapping ions, trapping electrically neutral individual atoms is a bit more difficult, but if you manage to do it, they'll disturb each other less. In their new paper, which was just published in Nature, they report that they set up an array of 60 atoms and managed to entangle pairs with a fidelity of more than 99.5%. This basically means they entangled what they wanted to entangle and nothing else. This is comparable to the fidelity of quantum computing approaches that have been around for much longer, like ion traps or superconducting circuits. So this makes atoms and tweezers quite a competitive approach now. Hello. Shoes that listen to music. No, I already have 2 teenagers. Yeah, thanks for calling. Bye. Researchers in the United States and Denmark have for the first time seen how sound waves spread in crystals. Here's how they did it. They shot laser pulses at a gold film on the surface of the crystal. The light caused the gold film to heat up and expand, which created sound waves inside the crystal. Then they used an X-ray beam to probe the crystal and measured its reflections at intervals less than a picosecond. That's 10 to the minus 12 seconds. It's interesting because the way sound waves bump around in materials reveals their internal structure. It's kind of like talking to my husband. An interdisciplinary research team in Germany has found a way to redirect laser beams with air. They have now applied for a patent for their device. Lasers are usually redirected with optical gratings that are flat surfaces etched with little parallel lines. But because most gratings are made of solids like glass or silicon, they get damaged over time. The researchers instead used pressure created by high-intensity ultrasound to modulate the air density. This redirects lasers for the same reason water redirects light. The refraction index is not equal to 1. In their recent paper for Nature Photonics, the researchers write that the grating can deflect light up to a power of 20 gigawatts. That's the equivalent of roughly 2 billion LED bulbs with 50% efficiency. This is only a proof of concept device, but it's a pretty cool method of contactless laser manipulation. It's also an idea that the military will either be very interested in or very interested in making disappear. The European Space Agency shared some gorgeous footage from Mars Express, its 20-year-old Mars exploration orbiter. The footage captures Noctis Labyrinthus, a network of valleys about as long as Italy. Noctis Labyrinthus, the labyrinth of night, is believed to have formed when volcanic activity forced the planet's surface to stretch, producing cracks up to 30 kilometers wide and 6 kilometers deep. We owe this beautiful footage to the high-resolution stereo camera of the orbiter. It's capable of filming at up to 2-meter resolution, and because it can also do 3D imaging, we get to see the topographical details. This isn't the first time Mars Express has captured footage of this area, but it's stunning nevertheless. Just a few decades ago, getting video this detailed was a dream on Earth. Now we're doing it on Mars, so at least something is making progress. Hello. Hi, Elon. To Mars in 3 years. Yes, if you could get me one in XS that says, Elon Musk went to Mars and all I got was this lousy t-shirt, I'd donate that to the Red Cross. I think they really appreciate your support. Sure, talk soon. Bye. A group from 2 UK universities is launching the world's first hurricane prediction market. The word market might make you think of fish, and while that isn't quite right, it isn't far off either. A prediction market is a way of collecting and evaluating information, not unlike figuring out which fish are good to eat or the stock market. Fish, stocks, Same thing, really. On the new hurricane market, users can bet on predictions and receive a reward if they're right. To limit noise, the betting on such markets is usually confined to experts. In this case, that'd be, for example, meteorologists, climatologists, and statisticians. The market is run by Crucial, an acronym for Climate Risk and Uncertainty Collective Intelligence Aggregation Laboratory. They're now calling for participants in the betting market. So if some of your best friends are hurricanes, you might want to chime in, and who knows, soon enough you'll buy Twitter and fly to Mars. Thanks for listening. We'll be back next week.